All right, cool. So my name's Keith. Let's wake my laptop up. I work at Slack. Out of curiosity, while my laptop regains consciousness, how many people here know what Slack is? No? Okay. Well, no, I mean, I've talked to a bunch of people. I've had to give the elevator pitch a bunch of times. And how many people have used it at work, out of curiosity? Okay, great. So I'd be remiss if I didn't spend a slide or two just plugging, because my employer did give me time to prepare this talk and stuff. Slack's a persistent group messaging application for work teams. Check it out if you haven't had a chance to yet. I originally got involved in PHP, the PHP world, in 2009 when I started working for Facebook. And not too long after that, me and Jason Evans and Drew Porowski started working on the hip-hop virtual machine, or HHVM. And a bunch of our colleagues there started working on a gradual typed superset of PHP called Hack. And following in sort of Go's footsteps of having an ungoogleable language name, that means Hacklang tends to be the thing that you can actually Google for, and the actual domain name and so on if you're looking for information about it beyond this talk. And a little bit of a roadmap for what's ahead. We're going to tell you about Slack's investment in PHP. It's a deep investment. It's not going anywhere. And we're also going to tell you, the real side of that experience a little bit too. We're going to unpack what Hacklang is a little bit. Part of my motivation in giving this talk, by the way, is that it's super exciting to me that in PHP 7 world, the community is getting excited about type systems. But there's a ton of confusion about what Hack is and doesn't do and what the overlap with what PHP 7's type system currently is. So we'll talk a bunch about sort of that margin of distance between the two of them. And if you're convinced that you have some of the problems that Hacklang addresses, I'll tell you a little bit about how to use it effectively. So I wrote a blog post last fall called Taking PHP Seriously that sort of talked about Slack's investment in PHP and the patterns I've seen in talking to other users of PHP that they've seen. And I think it's true that there's this apparent paradox at the heart of PHP that it's a bad language, and everybody sort of knows that it's a bad language, except people are extremely productive and make lots of successful things with it. And that should at least make us curious, right? That doesn't mean it's, those two things could both be true. And to cut to the chase here and save you a kind of long blog post read, they both are true. It sort of is a bad language, and it's a really productive environment. So PHP, the language, has a bunch of issues that can be addressed. And PHP, the environment, turns out to have a bunch of wonderful properties by a combination of design and accident and evolution. So we're wondering if there's a way to keep some of those nice environmental properties, right? To keep some of the effects of using PHP at scale that we experience at Slack, while making some of the things that PHP makes more difficult than they ought to be a little easier. Just a bit about our environment. We're just shy of a 500,000 lines of code under management at Slack. Just a little over a quarter of that is test code. Test code is also code, and it's expensive to maintain, the way that code is expensive to maintain, right? So the joke would go that, I had a program and I needed to test it, so I wrote a test program, and now I had 2 programs. We're pretty close to a bare metal PHP shop. We're not on top of sort of a popular framework or anything. PHP and MySQL are the frameworks, essentially. We use kind of Smarty for the UI, for some of the server-side UI render, and we use a handful of other open source libraries. But most of those KLOCs are things that the engineers at Slack actually wrote. And PHP has been very good to us. There are some really good things about PHP. Our near CI infrastructure lets us deploy about 40 times in most work days. Sometimes that goes up to 50, sometimes it goes down to 30, but we do a lot of deploys. We buffer a couple of PRs in most of those deploys. So there's something like 100 changes, 100 atomic Git changes going out per day. One way to look at this is that most people who work on PHP at Slack change production every day, most days. And PHP has these nice things as a developer environment, right? It made a bunch of great decisions around state, right? It's sort of orientation around requests and saying that you start with an empty heap and an empty namespace with every new request that comes in. Gives you a fault isolation boundary. It reduces the cost of bugs. Saying that there is concurrency, but the concurrency comes in the form of web requests and no other form. Powerfully simplifies a lot of application logic. And most importantly, it just has a great workflow, right? You could make something that sort of solves all the theoretical problems of PHP as a language, but if it took sort of 5 seconds to compile before I could see whether I made things better or worse, you'd just sort of be messing up the applied psychology of that PHP workflow, which is just, I saved, did I make it better? I saved, did I make it better? Okay, so now the difficult parts. As part of sort of normal maintenance and grooming and care of a big code base, there are various things that you want to do, right? For instance, you notice that all of the things, all of our search routines go needle and haystack, but you found one that goes haystack then needle, and you'd like to change it around. You would like to sort of change the kind of data that something returns and convince yourself that all the things that consume it actually are safe now. Or maybe you just want to rename something, right? Something just has a typo in its name. Somebody actually misspelled something in the name. Or the name's not is subtly misleading in a way that led you to make a mistake, and you want to prevent the next engineer who stumbles over this from making the same mistake. And the experience of doing this in a big enough PHP code base, and by the way, to be clear, this works totally fine for 10,000 lines of code, and only begins to be a problem a little tiny bit at 100K lock. And by the time you're at 1 million lines of code, it actually this is really, really major surgery sometimes, right? So it feels like you're just going to the dentist to get your teeth cleaned or whatever, and next thing you know, you're waking up from major surgery, and your jaw's been wired back together, and a couple weeks later it still hurts. And if that's your experience every time you try and do something that's sort of basic hygiene, it's going to make you a little reticent to do the stuff that you really ought to do. People make coding mistakes a lot. Typical PHP code bases often have return values that are dictionaries where there's just a convention about what the keys in the dictionary mean. So for instance, there's a lot of code at Slack that returns an array that'll have a field named OK that's Boolean, either true or false. And then if it turns out to be OK, it'll have some actual payload, named data or something that's a string. And if it's not OK, it'll have some other payload, right? It'll have a member named error that's a string, or error code that's an integer, or both, or neither. And that works just fine sort of when it just has to fit in one person's head. But when there are 1,000 call sites of this thing, and it's subtly different in all the different places that return things with OKs in the array and stuff like that, it gets really hard to convince yourself that you're actually making a safe change. One of my favorite ones here is that since it's so hard to change code, and it's relatively easy to just write new code or really copy new code, you end up sort of finding these little trails of copy pasta where every module has its own little copy of the thing that turns a user into their team, for instance, right? And then you see one of them that's just a little different. And you need to figure out whether the different one is right or all the other ones are right. You start going through code history, you start git blaming things, trying to figure out whether there's actually some really deep reason that this actually is subtly different, and whatnot. And a very different kind of problem, and I'll admit not everybody thinks they're up against this problem, but more things are up against it than you'd tend to expect, is actually that there's a lot of I/O parallelism latent in PHP workloads that we don't exploit really well. What do I mean by that? I mean that there's actually a lot of activity that could be going on in parallel off the box. Right? We could still be sort of running our single thread of PHP control, still reasoning about PHP programs the way we're used to reasoning about them, but we could have 2 or 3 or 4 or 5 databases doing work for us while we do that. Or we could be doing 100 memcache fetches while we do that, or some weird mix of all of them. But gosh, do we not want to end up doing sort of general purpose threads? I can go and, maybe that's not it's lovely talking in front of a PHP crowd, by the way, because I'm used to sort of having tons of boilerplate and being oh, threads are lovely, and I know that you love threads, and I know that you're smart people, and you'd never use locks wrong, and so on. But let's just take it for granted, since we're all PHP users, that we understand that it can be a problem to have shared mutable state in a concurrent program. Cool. So what do people do when they hit these problems? Well, so number one of the bullet for what people do with these problems is just kind of make excuses and pretend they're not happening. Right? So that's kind of almost like all other problems in life, right? Just like you do when you have a toothache or whatever. You kind of say, well, is this really so bad? All programs get hard to modify when they get large enough, and so on. It's true, all code bases do get harder to modify as they get large, but that curve has a different shape for different languages. That's part of the reason that people have different preferences for different languages, is that they've developed those preferences in different contexts, right? The other thing you see a fair amount of happening is that you sort of hit pause on everything and just rewrite it all in some other language. Nowadays, sometimes it's Scala, but typically it was Java. It's always a JVM-based language for whatever reason. And then there's sort of version 2 of that, the thin end of the wedge version of this, which is rewrite it all in favorite lang, But I'm going to do it a little bit at a time. So we'll carve off search and then do that way, and then we'll carve off, authentication and do it that way, and so on. And I don't like these answers. And I have a better answer. That answer is Hacklang. Hacklang is a gradual typing system that's worthy of the name type system for PHP. It lets you, what we mean by gradual typing, that's sort of like programming, PL theory speak for, you don't have to buy into it all at once all the time. That you can use it in a little bit. If you type more, you get stronger theorems proven about your program. If you type a little, you still get a little bit of safety. It also is meant to richly interop with real PHP, right? So as you'll see up ahead, Slack's codebase is a pretty motley mix of sort of real PHP and Hacklang right now. All right, so I'm going to attempt to actually do this live. Can we see that? Is that visible at the back of the house and everything? All right, cool. So this is a stupid PHP program. This stupid PHP program prints a bunch of the Fibonacci numbers. So I've got this implementation of the Fibonacci sequence here. It turns out this doesn't actually work correctly for whatever reason. Those aren't the Fibonacci numbers. Well, okay, so you can opt into sort of being type checked by Hack by saying this. And whoops, without me running any code, right, without me invoking a PHP runtime of any kind, my editor, and my goodness, that's terrible highlighting, but my editor has told us that I made a little typo. There's an undefined variable there in column 26 of line 3. And by the way, when you first get into your PHP code base and start slapping HH into the top of it, you find a few of these. They're probably not right in the middle of the hot path the way this one is, because of course this is rigged for the purposes of the little cooking show we're doing together. But now I saved it and it's happy. By the way, I'm using Vim here, which kind of marks me as an old fuddy-duddy, but there are Hack integrations for your favorite editor if you so choose. A lot of the kids at work are using Visual Studio Code these days. Okay, cool. So let's see if that worked. Oh, it did. Wonderful. Just trust me that that's the 30th Fibonacci number. Right. So what else can we say about this? So we can also do the stuff that PHP 7 wants us to do, right? We can say, use sort of some of the same slots in the syntax that PHP 7 consumes. And boy howdy, it's telling us that this is a bad invocation of fib. Of course it is. This is still a toy program. So, cool, you can say scalar type hints the way we're used to saying scalar type hints, but notice I don't need to write a unit test to do this, right? Because we have a real type checker and a real type system here. I can also say, that this returns an array, right? Because it returns the results of array map, which is still true. Yep, that's true, good. But gosh, that's a really unsatisfying thing to say. I know a lot more about this than that it's just an array, right? Is this an array that's like a dictionary that maps, names to phone numbers? Is this an array that is just a densely packed bunch of floats? No, it turns out it's an array full of ints, right? And I can say that it's an array full of ints. And in fact, if I got that wrong, oh, damn. Here we go. This is what I need to do. Yeah, that's a long story there. Right. That's because I can't type this thing. Oh. Well, yeah, I'm not sure I get why that's allowable, actually. But if I tried to treat this thing as if it were a string, well, I'm not sure why it's like letting me do this right now. Yeah, perils of live coding demos. Bear with me. So I had backup slides in case none of this was going to actually work, but luckily I was able to hit Alt-Tab. In terms of where you put these type annotations, right, there's a concern with all these systems that you're just going to turn into Java, right, that you're going to have to be saying like, oh, okay, like hack.lang.collections.something. Every time you turn around. There are 3 places that the type annotations can appear. They can appear in return types, parameter types, and class members. That's all there is to say about it. All the other stuff is done inferentially. It figures out what the temporary values are. It figures out what the locals are from what's on the right-hand side of their assignments. And if there is no right-hand assignment, it warns you like we saw with $M earlier. All right, cool. So because they look super similar, and because they're occupying similar slots in the grammar, and because both of them give you scalar type hints, which is a thing you're not used to seeing before, it gets really confusing to talk about this in a room full of people who think in terms of PHP 7 type hints. So just be patient with me for a second. We're all going to get through this. The type checker runs dry, right? It runs on a sort of mindless, non-dynamic view of the universe. It just knows where the source tree is and what you've typed on disk. It doesn't know what you're going to do at runtime. That's actually an advantage, because in some sense it's checking all the paths at once. Right? You don't need to write unit tests that cover every single branch. Whatever can be proven about the types is being proven, in parallel. Since the type checks aren't running at runtime, the type checks can do things that would be too expensive to do at runtime. Right? So before you saw me talking about an array of integers, actually checking that something's an array of integers, if you don't have some sort of offline proof that it's the case, is going to take about as long as that array is long. Right? You need to actually have proven that it's an array of integers to have that be a useful type constraint that you can actually make sense of in a program. And getting this power with it makes a couple of other things possible, right? It makes generics and shapes possible. We saw a little bit before the single parameter version of array. That means that you've got a densely packed array of things, right? So this little word frequency program here takes a bunch of words, maybe you got it by tokenizing some text file, and it gives you a histogram of how often they all occur. This is mostly just to show off the sort of two-argument form of array, right? So sometimes you use arrays as dictionaries. When you do that, you take this two-type parameter version of array. The angle brackets thing there is kind of de facto standard in a lot of languages now for type parameters. You've seen the primitive types. We've seen a couple kinds of arrays now, but now I want to talk about a kind of array that crops up a lot in PHP programs that it's hard, that initially feels like you can't capture with your type system, right? So you remember I was talking before about that sort of OK idiom? This happens all the time in sort of old school PHP programs, right? Where people basically want a struct in C, right? They want to sort of say, this is going to have this field that's an integer, and that field that's a string, and this other field that's like an array of strings or whatever. The way to express that in Hack is a thing that we call shapes. And shapes are closer to Go's structs than C structs in a way that we're going to see in a second. The way that they look, so this is a type name here, that third bullet point. It's a type named shape that takes all those things. It's a compound type, right? Types can refer to other types. It looks a little bit like an array literal, but instead of saying array, you're saying shape. And instead of values, you have other types. So the interesting thing about shapes is that the reasoning about subtyping in shapes is permissive. You're allowed to have too much shape. So for instance, if I had something that has all the fields that that type requires, but then also has some other stuff in it because we're crazy and because we went down some weird path or whatever, that's fine. That's actually OK. This type checks, and it's intentional that it type checks. And we'll see why we want that to be looking at this slightly less goofy thing. So I'm taking this tutorial from an excerpt of a tutorial I did sort of internal to Slack, and part of it is a little miniature world's crummiest Slack clone, and we're looking at it here. And one of the things it has is users. Right. So I didn't talk about it yet, but you can also alias types. So it might be useful to talk about user IDs without caring whether it's an int or a string, or getting confused about whether it's an int or a string. So those are user IDs. We're also going to give this shape a name, because users keep coming up in the program a lot, and it gets kind of tedious to say all of this stuff in the program. But they're users, right? And they've got IDs and emails and all this like nice small stuff. And then we made a bad sort of database schema design decision, right? We had some column in the database that just is gigantic. And this is the base 64 encoded version of their profile. And it's a string that's a binary string that's a PNG or something, right? And it seemed like a good idea at the time, and we had to rush, and we did it. But there it is. We've got this goofy thing that every time we materialize a user from the database, we've got a megabyte of pixels sitting there in the PHP heap. OK, cool. So 2 years later, you want to cache users in memory. And you realize you can't do that because these base 64 profiles are going to blow out the memory budget for all of your requests. So you decide that there'll be these kind of lean users. I'm calling them a min user right now. That just gets the stuff that you just barely need, right? And a min user is going to only have these two fields. So the pattern that this is intended to capture here is that you can use a user where you just need a min user, right? Which is, but you can't go the other way around, which is the source of a lot of bugs in programs that try to take shortcuts like this, where if you've got a sparse set of columns from some database row, and then you pass it somewhere that, something more complicated that expects there to be sort of columns that aren't present. So if we look down here, this user min thing, right? This is how you go in this program from an ID to one of these minimal users. If we find it in the cache, we return it, and that'll be one of the minimal ones. But if we don't, we go dig it up from the DB, and we've got a megabyte of extra junk in there. So before we record it in the cache, we put it in there. And then we get it from the cache again, knowing this time that we'll succeed. But we could just as easily say, return the raw return value from the DB ret. Oh, we got angry about this finally. Yeah, we know. That was the point of that. And this one, is it saying something reasonable? Oh, OK. I misremember how this program works. Let's see, what's the actual? So the kind of pattern here is if you're used to thinking of type systems from object-oriented world, like if you just get rid of traits and inheritance or interfaces and so on, and just in sort of classical object-oriented world, you're used to the subtype relationship being a hierarchy. Right? You're used to the idea that like there is some root object that has almost no identity, and there's a big complicated forest of things hanging off of it. Shapes are lattices. All right, so every shape is a member of this empty shape type. And that empty shape type has, arbitrarily many unary children. Each one of those children has arbitrarily many binary children. But for this little bottom shape down here that has those two fields in it, it would pass a type check for any 4 of these things that are on the screen, right? All the way backtracking any route from any path where you flip the arrows from one of these things back to the empty shape. Those are all the types that your shape contains. And it turns out this formalism kind of captures a lot of the ad hoc stuff people do with arrays pretty well. So I admit this shape thing is kind of trippy and takes a while to absorb. In terms of runtime implementation, by the way, these are just really arrays under the hood. Like they reserve the right to do something different, but this is what they do for now. All right, cool. So something a little bit different now. These first few things were sort of purely front-end stuff, right? And at least when I stopped working on it, I'm told this isn't true anymore, but when I left the HHVM project, all of these like type annotations I've been slapping on, the front end mostly just threw them away. The front end mostly parsed them, said, oh, that's nice. That was there for the type checker, not for me. I'm just a PHP engine. I'm just going to run your PHP program. This part does involve some runtime changes, so let's get our antenna up for a second here. So you've got an endpoint, and for whatever reason, it needs to fetch 100 users' records. And you're in a situation where you've had to scale out a little bit. Right? So it's no longer the case that you can just do a select in one place. The databases are kind of spread out in a couple different places. Or maybe it's a slightly more complicated access pattern. Right? So you're hoping that all 100 of those things will hit in memcache, for instance. But some of them are going to fail, and you'll need to fall back to some databases. There's a kind of relatively natural way to do this, which is going to be this thing here, essentially. Ignore the thing starting with async for now. You want to turn an array of user IDs into an array of min users. So you're just going to array map this thing that we just saw that fetches users from either the cache or the database over those users. Seems reasonable, nice and concise. We kind of wrote it in this cute functional style. But the problem is that that thing is going to be completely serialized. Right? So it's going to take, even though you might have 100 databases out there that could work on this perfectly in parallel while your application code runs on and does other stuff until it's ready to actually start getting data out of this thing, you're going to go to database 1, talk to it, go to database 2, talk to it, go to database 3, talk to it, and so on. So you can get really terrible performance on this when there's a very clear opportunity to run in parallel here. So there is a combined runtime and language solution here that's async and await. And this is a conceptually rich little chunk of code here. So bear with me. It's really hard to explain without some forward references. But there is a new type in the world. It's a waitable. And a waitable is a generic type. It takes a type parameter. And a waitable is a handle into a in-progress computation that's going to return its inner type. All right, so an awaitable of an int is some in-flight computation that will eventually return an int. If I am in async land, I can use this new keyword await. And in async land, that await keyword does a couple of things. For one thing, in the sort of thread of control that you're currently running in, it doesn't keep going until the awaitable on the right-hand side of it is done. As a practical thing, it's a point where cooperative multitasking happens. So if you boil away, the actual syntax here, what's going on is that there is a coroutine system in the runtime that's actually managing all of this. So instead of having a call stack in a program that uses async and await, it's actually a call tree. And each leaf in that tree represents an in-progress awaitable that's executing. So the cost of one of these awaitables isn't anything close to like an operating system thread. It's not something the scheduler is going to worry about. It's not something that's going to hold on to a ton of resources. It's really just however much PHP goo is on the stack between it and the that you had to get there for. So they're very cheap. We can have thousands of them running around at runtime relatively inexpensively. They play nicely with the type system that we just outlined. Another claim that's a little complicated to explain about them is that they compose. And what I mean by compose is that, so curl, for instance, right? The curl library has a way of doing async I/O. But the curl library's way of doing async I/O is distinct from libevent's way of polling file descriptors, right? Whereas if you have a set of async awaitable handlers for these things, you can just as easily fit a memcache await. You can have interleaved things for from different libraries running at the same time. There's nothing that constrains all of the in-flight awaits to be of the same type or touching the same backend. So for instance, you could have hundreds of memcache gets going over here, hundreds of MySQL gets going over there, a bunch of curls to Solr to try to index something going on over there. And all of these are sort of relatively inexpensive in the runtime and lets you exploit parallelism off the web machine that you're actually running on. So let's say for the sake of discussion that you're completely sold on this and you're clamoring, you desperately want to gradually type your big PHP code base now. You now have a choice, right? That's the whole part of gradual typing. You have to decide what to type and where will it be useful, where will it actually stick, how will we learn something useful from adding this to our code base. So having seen this in a couple places, I have an opinion about this that I can't quite prove, but that I think has some reasons to think it's true. So you've got your big ball of code, right? And there's different ways of looking at it. One of the ways of looking at it is a sort of a layer cake diagram. You've got stuff at the very low level that deals with data, things in the intermediate levels that deal with sort of more and more abstruse levels of application logic, and then presentation way up at the edge. And if you just kind of throw a dart at that pile of code and you just pick somewhere in the middle and put some types in there, the odds are that it's going to interface sort of above it, below it, to its left, and to its right with untyped code when you're starting out, right? Because there's nothing else for it to kind of latch onto. And the power of types is in the contracts that they enforce, right? They're a form of communication across code boundaries. So that's sort of a pessimal place to start in some ways, right? Because you don't know if you got it wrong, right? You might have sort of like taken a wild guess at this, but for all you know, all the callers above you and all the callees below you actually have somewhat different expectations than your initial guess. So let's say, for the sake of argument, you start at the bottom of the stack, right? You start the stuff that has to be that's a database access. That's always untyped. And by the way, that's untyped in C++. That's untyped in Haskell, right? It is always the case that the thing that actually takes bytes off a wire or off a disk or whatever, however fancy your programming language is, that it takes the keys that people are actually typing in keyboards, right? There has to be something that actually interfaces with physical electromechanical devices in the real world that is not captured by your type system. So you know that thing at least has sort of one surface where you can reason totally about what it should do, which is its return type. Right? The thing that sort of slurps stuff off the wire and either says, yes, this is a well-formatted widget, or throws an exception, really does return nothing but a widget. So you have a chance of actually getting that right. So similarly for the very top of things, the very top of things too tends to actually be interfacing with the outside world. Right? The very top of things tends to be talking to HTTP or talking to whatever the sort of outer edge of this service actually is. So intuitively, you can sort of think of the process of moving from entirely untyped to having mostly typed code as a kind of phase transition. And there are sort of practically better and worse ways to freeze a big blob of water. And it seems like code does better if you sort of start freezing it from the bottom. One of the things about I've seen this happen in 2 big code bases so far. For what it's worth, when we were at Facebook, we started at the top. And that was actually just because there wasn't a lot of buy-in yet. It wasn't clear this would actually be helpful or work. So there were a handful of partisans that were really excited about it. People were kind of willing to tolerate their excitement about it. So they would write new code this way. And what happened then was that they sort of started falling into a pit of success. And people were like, wait, why are these people getting all this stuff done? How come they're having lower defect densities? How come they're talking at the water cooler about doing changes that I'm afraid to do? And it sort of socially grew from there. But you can also start from the bottom if you've kind of got enough of a mandate. And people at Slack were collectively excited enough about it that we've been able to start from the bottom. Another little hint about this is that there's an asymmetry here about return types and input types. It's easier to get return types right. Return types are a local property of the code you're looking at, whereas the input types to it are a global property of the entire program. So in practice, a lot of times if you're sort of doing a sweep over some chunk of code trying to get it more well typed, you'd first sort of go in, do the return types. Those will enable you to start propagating return types up from the next layer up. And once you've sort of covered that layer above it, you can start drilling parameter types in, and there's enough HH and enough sort of things that the type checker can get insight into that next layer up can actually do work for you. So this is still work in progress that I'm talking about, by the way. Slack's not all the way there, I don't think. We're not in equilibrium yet. We have 4,500 PHP source files in our main repository where most of our application logic lives. And it's about half and half HH and PHP. There's a fair amount of open source PHP that we're using that we're never going to mess with because we want to follow open source for those. But of the ones that are ours, a thin majority are HH, and that's trending up over time. A little over 10% of those are in strict mode. So if you say HH//strict, you're asking the type checker to insist that everything be typed. Right? So every method and every function that you define in a file like that needs to have all of its parameters and all of its returns labeled. So some of this stuff is, it's not just like we slapped HH at the top and got rid of all the undeclared variables. We're actually beginning to use it. The async stuff is still the bleeding edge of things that are happening at Slack right now. It's relatively new that we have performance critical workflows where a single request needs to touch dozens and dozens of backends. So we've been using async kind of tactically so far. It's not the default way of doing all the I/O. Most of the I/O is still happening with synchronous interfaces. We're in the process of moving those synchronous APIs to use async under the hood just so that we get more confidence about how we transition over to it. And when you talk about sort of a weird project like this, people always ask, admit it's an unusual project. People want to know, well, did it work or not? Right? Did you have lower defect density? Are you able to deliver changes more quickly? Are you higher confidence? Are your customers happier? And unfortunately, it's not a controlled experiment, right? I didn't get to fork the Slack codebase and, split our developer community in half and, do a perfectly controlled, left A/B test on whether hack helped or not. Most people think it is helping. A certain amount of excess energy goes into doing this when people, when people see so. I have never, I've been reticent to have things like quarterly goals around making these numbers go up. I don't think that's a sensible thing to do. So it's not like there are managers running around with guns to people's heads being like, type more things. To the extent that devs are choosing to do that, it's because they're opting in. So if you're curious about more of this, there's a web tutorial online that takes you through a whole bunch of corners of the type system that I didn't get into here. If you have any PHP that's written in a functional style, one of the really fun parts is that you can type anonymous functions with a lot of richness and in a really pleasing way. It turns out you can't quite make the Y Combinator, which is like, read the book to find out. And my colleague and friend Owen Yamauchi has an O'Reilly book about Hack and HHVM, and the chapters about async generics and Hack greatly influenced this talk and my practice. Okay, so what do we learn here? So I don't think by any stretch, by the way, that this is the most important thing for many, many PHP projects to entertain, right? Not all code bases become enormous, right? Not all of them have lifetimes or horizons or roadmaps that are, unboundable in their complexity. But it happens sometimes. And the projects that it happens to tend to be the projects that a lot of value and a lot of developers are attracted to, both in open source and in proprietary settings. And if that happens to you in PHP, I think we should admit that that's a problem. Like the curve for how things slow down and the kinds of molasses you get stuck in generic PHP is a little harder than the curve that you'd face if you'd started out in Java. That's the price you pay for the early part of the curve being so nice. The good news is that there's a solution short of rewrites, whether incrementally as a microservices or monolithically. And also, if there's one thing I want you to take away from it, it's that shapes and async are really exciting magic, that they're very powerful. There are lots of sort of typed languages that the cool kids on Hacker News talk about that don't quite have fully working equivalents of these things. And I would love to see it more broadly adopted, whether as part of Hack or part of some other future son of PHP 7 that we're able to move on to. So I think we've got a bunch of time for questions. This is a little sticker that we give out to people who do big changes that migrate Hack over. There's a little Hack logo in a heart. It's cute, right? And with that, I'd be happy to kind of answer any questions y'all have before we go out for another coffee break. Is there anyone running around with a mic? No? Yeah.
Here we go.
Is there a way to represent optional fields in a shape?
Yeah, so there is. It's a slightly complicated story. So the way that you represent an optional field in a shape, actually I'll just do this, the nicest version of this here, is with this question mark. So this is a generic wrapper around something that might fail, what we call a result of this type. It has an OK. The only thing we know for sure is that it's got an OK field that's a Boolean. And then it might have a result, or it might have an error, or it might have an error code. But this is the notation for a nullability, by the way. So this actually kind of, there's a little bit of a wart in it, by the way. Like there's actually, if you wanted to express, there has to be a results field. It's just the results field is a nullable t-success. There's like no way to say that. The only way to say that in a shape is to say there's an optional results field. What are you going to do?
Questions?
Cool. Anything else tactical? Yeah, shapes are neat. And if you wanted to kind of, if you're curious about how you make something like that work, right? So there's a bunch of result kind of helpers lying around here. It gets annoying subscripting for results all the time after one of these things, and subscripting for OK all the time. So you make a little get thing. This get thing's generic on t-success that returns the t-success, and you force people to check. Right, so this thing kind of upcasts one of these arrays into, this is, how you check that somebody tried to get something that they're not allowed to get. But this is a runtime check. Cool. So demand nothing less from your type system. It should be expressive. It should be recursive. It should be able to express complicated things that you know are true about your program, more complicated than that this thing is an array or a string, right? Yeah, I look forward to kind of interfacing with y'all about what you find valuable and less valuable in your type systems.
Thank you very much.
Yeah, thank y'all.
Keith, if I could have just one more moment of your time. I was curious to hear, I had one question, final question. PHP 7 and Hip Hop VM are both pretty powerful, right? What's your take on using them together, and do you feel like there's a lot of value in both sides, or what's your perspective on that?
Yeah, I mean, I don't really have a dog in this fight anymore. Like, honestly, HHVM was built because it filled a business need in Facebook's history. If it continues to for Slack, we'll keep using it. If something comes along to supplant it, awesome. The kind of current story around PHP 7's type system is that it's runtime only, right? So it's like it's syntactic sugar around guard statements, which is great. It's something, and it moves the ball in the right direction. And it's a conservative step, and there's enough other stuff going on in PHP 7 that I understand why a conservative step was the one to take then. It is, I haven't thought hard about it to say for sure. I'm not sure what the kind of roadmap for PHP 7 and children of PHP 7's type systems being able to kind of express some of this stuff looks like. But yeah, I mean, if async comes along and if generics come along, or an even better version of something that subsumes all those use cases, wonderful. Nothing would make me happier than to port over. For now, there are sort of slightly different use cases they address. And in practice, like if I reflect on sort of the community of people that have found HHVM and Hack useful versus the ones that are way more excited about PHP 7, like HHVM and Hack address kind of industrial code production environments, right? They are addressing environments where you have hordes of people working on a gigantic code base, trying to make lots of features at the same time and not step on each other's toes. And that's not the environment everybody's in. So that's perfectly fine, right? If this sort of stuff isn't appealing to you, then that's not your problem.
Thank you very much, Keith.
Cool. Thank you, Eli.
Next sessions will begin at 3 o'clock, and we'll see everyone back here later for the party.